Beneath the vast emptiness of the Pacific Ocean, the largest tectonic plate on Earth may be starting to fracture. Strange earthquakes are popping up in places they should never exist. Volcanoes are punching straight through solid rock, and entire chunks of the plate, once thought unbreakable, are peeling away. If this giant really is cracking, the consequences won't just reshape the Pacific, they could redefine the future of earthquakes and volcanic eruptions worldwide. So how close are we to a breaking point? Let's dive in. The Pacific Plate is a titan, a single slab of crust bigger than all of North America and Eurasia combined. It covers nearly a third of Earth's surface and drifts northwest at almost 11 centimeters a year. Fast, powerful, and immense. For decades, scientists believed this hulking plate was essentially solid, so rigid it could transmit stress across thousands of kilometers. It was the geological equivalent of a steel beam, steady, predictable, and stable. At least, that's what we thought. Because now, deep beneath the Pacific, that illusion of stability is starting to unravel. For most of Earth's history, tectonic plates only broke at their edges. Subduction zones, transform faults, spreading ridges. But then the Pacific Plate started breaking the rules. Tiny deformations began showing up in regions that were supposed to be completely stable. And then came the earthquakes, moderate, quiet tremors, occurring far from any known fault line. To geologists, this was like finding cracks in the middle of a skyscraper's support beam. These quakes weren't massive, but their location was the shock. They were rumbling straight through the plate's interior. This was the first undeniable sign that the Pacific Plate was no longer a single, flawless slab, but a puzzle of hidden fractures, some ancient, others frighteningly new. Earthquakes usually follow a script. They happen where plates collide, grind, or sink. But in the central Pacific, new quakes didn't follow any script at all. Near Hawaii, swarms shook the seafloor, far from any plate boundary. Elsewhere in the mid-Pacific, isolated tremors hit regions long declared geologically silent. Each quake was small, but taken together, they formed a pattern, a message. The Pacific Plate wasn't simply flexing. It was straining from the inside, as if deeper forces were twisting it in directions it was never designed to handle. Scientists knew what this meant. A supposedly solid plate was beginning to bend, and bending plates eventually break. Then came the smoking gun. Some of the strangest interior quakes clustered around volcanic hotspots, places where plumes of magma rise from deep in the mantle like blowtorches. Hawaii is the most famous example. Every island in the chain marks a moment when the Pacific Plate passed over one of these mantle plumes. But here's the part that caught scientists off guard. Every eruption required the plate to crack open, not at an edge, not along a fault, but through its own interior. Imagine a sheet of steel being pierced again and again by jets of molten rock. And the bending of the Hawaiian Emperor Seamount chain, nearly 60 degrees around 47 million years ago, proves these forces once shifted the entire direction of the plate itself. This isn't a plate that merely drifts. It's a plate that reacts, twists, and reshapes under enormous internal stress. And Hawaii isn't alone. Across the South Pacific, hotspots beneath Samoa, Tahiti, and other island chains reveal the same story. Rising magma is exploiting weaknesses inside the plate. Volcanoes are forming where no major faults exist, and fractures are spreading outward in patterns scientists are only now beginning to understand. But these volcanoes weren't the biggest surprise. The biggest surprise was what started breaking off. The Pacific Plate is no longer whole. Geologists have identified entire fragments, microplates, splintering from the main body. These pieces form where spreading ridges and transform faults intersect in chaotic zones called triple junctions. As the plate surges forward, stress builds at these weak points until the crust literally tears apart. Over millions of years, these splinters can grow, rotate, and carve the once monolithic Pacific Plate into a new mosaic of smaller pieces. This isn't speculation, it's already happening. And this isn't the first time Earth has watched a giant plate collapse. Tens of millions of years ago, another massive plate, the Farallon Plate, dominated the eastern Pacific. Today, almost nothing remains. It was swallowed beneath North America piece by piece, leaving behind only fragments: the Cocos Plate, the Nazca Plate, and the Juan de Fuca Plate. And one of those fragments, the Juan de Fuca Plate, is now driving one of the deadliest seismic threats in the world. The Cascadia subduction zone, capable of magnitude 9 megathrust earthquakes, capable of tsunamis crossing oceans, capable of reshaping coastlines. Farallon teaches a simple lesson: no plate, no matter how big, is immune to destruction. And now, the Pacific Plate is showing the same early symptoms. The Pacific Plate's instability isn't just an academic mystery, it's a direct threat to the 800 million people living around its edges. The Ring of Fire already produces 75% of Earth's active volcanoes, 90% of its earthquakes, some of the largest eruptions in human history. But if the Pacific Plate is cracking internally, stress won't stay contained inside the ocean. It will migrate outward, redistributing pressure along its boundaries in unpredictable ways. A crack in the middle can translate to chaos at the edges. This means subduction zones already primed for disaster, like Cascadia, Japan's Nankai Trough, and the Chilean Trench, could become even more unstable. And that leads to the bigger question: what does Earth look like if this colossal plate actually begins to tear apart? Some scientists believe it could eventually split into 2 or more massive plates, divided along weaknesses already forming in the South Pacific. Others think it will slowly shrink, consumed by subduction at its edges. And some propose an even more dramatic future. New rifts could open, a new spreading center could form, and the Pacific Ocean could begin evolving into an entirely new basin. These events unfold over millions of years, but the first signs of these future boundaries can appear far faster, and those first signs may already be here. Microplates in the South Pacific breaking free. Hotspot volcanoes forcing magma through the plate's interior. Mysterious quakes erupting where no quakes should exist. These aren't random anomalies. They're pieces of a larger pattern, a pattern that points to one unsettling possibility. The Pacific Plate is entering a new phase of its life, one defined by internal stress, spreading fractures, and increasing instability. And the timing matters. Because if pressure is already shifting inside the plate, then the planet's most dangerous subduction zones may be closer to failure than we think. Cascadia last ruptured in 1700, sending a tsunami all the way to Japan. Japan's Tohoku quake in 2011 triggered a chain reaction of disasters. Chile's 1960 earthquake, the strongest ever recorded, hit magnitude 9.5. These events were triggered at plate edges. Now, imagine the same stresses being fed by fractures inside the plate's interior. Pressure coming from both directions. Fault lines pushed harder than their historical limits. Subduction zones forced to absorb strain they were never meant to take. This is the scenario scientists fear the most. Internal cracking triggering external catastrophe. And it leads to the final, urgent question. The Pacific Plate is restless. Its interior is changing. Its edges are tightening. And the signals rising from the deep ocean are growing harder to ignore. Earth's largest tectonic plate will not stay the same forever. It will evolve, it will fracture, and one day it will fail. The only question left is, when the Pacific Plate finally breaks, what will break with it? If you want more documentaries like this, covering Earth's hidden forces, megaquakes, and volcanic mysteries, make sure to subscribe.